All right. Too much? Okay, all right. Okay, my name is Johanna Brown, and I'm a real, live chemistry teacher. And nothing ruins science like not understanding the math that's happening in class. I'm sure you've been there too. So today I'm going to talk about significant figures. You might know them better as Sig-Figs. Some people say significant digits, but I don't, so we'll call them Sig-Figs. All right. Most of this is going to come from the fact that you're going to get a lot of banal, angry comments from your chemistry teacher if you don't follow the rules of Sig-Figs. And I want you to think of it as something that's reasonable, something you might practice, and something you maybe even want to understand and use. So let's talk about measurement. And I'd like you to go way back in time with me, way back when all humans did was hunt and gather their food. And they didn't have to measure things. They just had to count 3 wildebeest. Not a big deal. But then we started farming. And when you start farming, you start trading. And if some dude over here is trading me barley for my 3 sheep, how do I know that he's giving me enough barley? I don't. I have to measure that. So we started learning how to measure things. And we started doing it with actual hands, like we measure horses today, or even a foot. But all of this was based on a king's foot. And when one king dies, you get a new king, you get a new foot. Life is really sucky because you're always having to change your rulers. And that's just not fun. So luckily, humanity went through this thing where we kind of got rid of kings, and the French Revolution really did it for us. So that's when we started getting standardized measurement, which is a huge deal. We got the metric system out of that. So thanks, French people. You killed it for us. All right. So what I'm trying to get at with this whole diatribe on measurement is that humans made up measurement to serve their needs. So pretty much anything humans do gets a little messed up. There's going to be some error associated with every single measurement. And that's what Sig-Figs are all about, tracking that error. So let's measure something. I have a nice little line here that we need to measure. And I'm going to look at it, line up. I'm going to use centimeters. Please use metric. Don't use inches anymore in chemistry. Thank you. Okay, so we've got it measured, and it's definitely between 10 and 20 centimeters. So I'm certain that I have got at least 10 centimeters here. So I can write that one here. Okay, good. Next part. I am certain that we are between 10 and 11 centimeters, okay? So I can write the 0. Now, we have a problem. Because this measurement is between tick marks that I don't have anything to give me information about. So what we as humanity have decided is that we are going to count one place past the tick marks, and that's where we are going to be able to estimate. So when you measure a number, you measure all the tick marks, you go through all the numbers, and you're going to get to a spot where there aren't tick marks anymore, and you get to estimate that number. So when we look at this, we end up getting our measurement being 10.4 centimeters. We call this estimated digit the uncertain digit. Is it still significant? Yes, we wrote it down. It's important. It's significant to our understanding of the measurement. But it's not considered certain. I didn't have 2 tick marks between which to assign the value. So the next part of significant figures is the fact that you've probably learned some rules about zeros. And zeros, for some reason, freak everybody out. So let's break them down. This first number that I wrote down, we're going to analyze this. We got 10.4 centimeters when we measured our line. Obviously, all the non-zero numbers are significant. We got them from something. We measured them. But the 0 between, people kind of think of zeros as not really a number. But we did measure it. We know that that was the value of this. Our actual measurement is 10.4. So that 0 is considered significant. It had to be measured. All right, so let's look at our next question. What if we put a bunch of zeros at the front of our number? Well, then we get 0, 0, 10.4. Do those zeros matter? Do they do anything to the number? No, they're not significant. So any 0 you're putting to the left of your measured number never counts. Good to go. Okay, what if we put a bunch of zeros on the back end? Well, if we take our 10.4 centimeter number and put 3 more zeros, I'm actually falsifying my scientific data right now, and we all know that that's not cool. When another scientist looks at this and they read this number, they think that this last zero is my uncertain number, when really it's the 0.4 way up here. So you can't just tack on zeros at the end. And if you tack on zeros at the end after a decimal point, that means that they were measured, okay? We'll practice this in a little bit. Finally, scientists deal both with really small numbers that you have to get used to and with really, really big numbers. So we had to come up with a way to express really big numbers without getting confused with the significant figures. An example of this is if I tell you, you know what, scientists have figured out that the universe is 14 billion years old. You just automatically understand the fact that I don't mean it's 14 billion years old to the nanosecond of the moment you're watching this video. I mean 14 in the realm of the upper 13s and the lower 14s, right? So when I say 14 billion and a big number like that, all those zeros to the right without a decimal place don't count as significant. So that 14 billion number really only has 2 significant digits. What? Oh, apparently we figured out that it's 13.7 billion years, but pretty close. So really we should have 3 significant figures. And what number carries the error? That's 7. And all those zeros don't count as sig-figs. Because you understand, and I understand, that a big number like that isn't going to count all the way out to the last number. All right, I think we're doing okay. We're going to finish up by doing some practice problems. Feel free, when I ask the question, to pause the video, try it on your own, because nothing makes a good chemist like practicing. So, question 1, let's look at this number, 1002. How many significant figures are in this number? Well, we have all of these numbers, and I'm telling you that they're measured, right? We have zeros in the middle. Those had to come from somewhere. So your answer should be that there are 4 significant figures. Which number is uncertain and yet still significant? Well, it's the last number that we reported that was measured. So the 2 is uncertain. Question 2. Looks like we've got 1,200 here. How many sig-figs are in here? Okay, this is like our 14 billion example. We have 1 and 2. These were measured. We have zeros without a decimal point, so we have 2 significant figures. Where people get confused is they're trying to figure out which one's uncertain. Well, these zeros weren't even measured, so they don't have any uncertainty with them. So our last reported significant figure is always the uncertain digit. So our 2 is the uncertain number there. Question 3, 1.200. How many significant figures? Let's look. When we have zeros after the decimal point, it means that we have measured numbers, even though they're zeros. Okay, so it looks like we have 1, 2, 3, 4 significant figures. The number that is uncertain is this last 0. It's our last reported measured number. Question 4. 0.012. How many significant figures? This is kind of a tricky one. We have some zeros, we have a decimal point. What should we do? Go back to what you think is the measured number. So if I had to get this number, only the 1 and the 2 came from something I measured. So everything to the left of that does not count as significant. So this number has 2 significant figures. Which number is uncertain? Well, it's our last reported measured number, the 2. Thanks for watching. I hope you learned a bit about significant figures and why we actually need them. Look out for my next video all about doing math with significant figures, and don't forget to subscribe. Have a great day.